Hi, in this video we will see one more example of inductive proof using mathematical induction. Consider sigma I is equal to 1 to ni. So that will be 1 plus 2 plus 3 up to n. So we have to sum up first all n number, and that should be equivalent to the equation n into n plus 1 by 2. So we'll try to prove it through 3 steps. The first one is we have to prove it for p of 1. Then we will assume that p of k is true, and we will prove it for p of k plus 1. If we can derive these 3 steps, we can say that it will be true for any value of n. So first step is the basis step for n is equal to 1. So our p of n, that is the statement to be proven, is nothing but 1 plus 2 plus 3 up to summation n is equal to n into n plus 1 by 2. This statement we have to prove. Let us call it as the equation number 1. For n is equal to 1, the LHS of the equation would be I is equal to 1 to 1, because now n we have assumed to be 1, and we have to sum all the i's over this range. So it is having only one possible value of I, which is 1. So answer is 1. The right hand side of the equation, if we replace n by 1, then that would become 1 into 1 plus 1 divided by 2. So that is also 1. LHS is equal to RHS, and hence we can say that P of 1 is true. So basis step is proved. The second step is an induction hypothesis. So where we are assuming that given statement is true for n is equal to k as well. So the equation 1 will become now P of k is equal to 1 plus 2 plus 3 plus k. So we are going up to some k, and we are assuming that it is true. So the right hand side will be replaced by k into k plus 1 by 2. In equation 1, we have to replace n by k. That's it. And we will assume that this is true. Now for next value, n is equal to k plus 1, we have to prove that it is true. So that is called proof of induction. In equation, so ultimately, we will put n is equal to k plus 1 in equation number 1, and we will try to prove that. So from equation 1, we have to prove that 1 plus 2 plus 3 plus k plus 1 is equal to, now n plus 1 by 2 will be replaced by k plus 1 into k plus 2 divided by 2. So all values or all n in equation 1 are replaced by k plus 1. So left hand side would be 1 plus 2 plus 3 plus up to k plus 1. Now whatever part I have shown here in red, that can be replaced with the blue part in equation 2, because from equation 2 we have already assumed that summation over k is nothing but k into k plus 1 by 2. So we are simply replacing that part from equation number 2. So we have k into k plus 1 by 2 plus k plus 1. The 2 is in denominator of the first term. To simplify it, we will multiply it with the rest of the terms, so that we can have a 2 in the denominator of entire equation. So this will result into k into k plus 1 plus 2 into k plus 1 by 2. In this equation, k plus 1 is common in both the terms, so we will take it out. So we have k plus 1 into k plus 2 divided by 2. And as you can see that it is same as what we were trying to prove in step 3. That is, that left hand side should be k plus 1, k plus 2 by 2, and that's what we are getting. And hence it is proved that P of k plus 1 is also true, and so our inductive hypothesis is also true. Thank you. That's it for today, folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.